Hey, what's up? It's Jake from Nimbus DevOps, and I'm here today to talk to you about Kubernetes ReplicaSets. So let's go ahead and recap on a pod real quick by creating one. So I'm just going to make a pod definition file, and let's fill it out. So we have our API version, which should be v1, our kind, which is pod, some metadata. So like we have the pod name, which I'll call like Nginx, and then some labels, and I'll say like app is our front end. Okay, and then I have my spec, which should have my containers. I'll use the Nginx image and the Nginx name. In addition, I'm also going to put in some resource limits of 1 CPU and 512 memory. Okay, so that's pretty much a pod definition file. And we can test this by running kubectl apply -f my pod definition file. Apply. There we go. And then we can run kubectl get pods. And everything looks good. So one thing I'm going to do before we start, I'm going to create an alias for this session. So I'm just going to say alias k equals kubectl. Now I can just type like k get pods, and it's much faster. If you're doing the certification exam, highly recommend doing that in your alias, an alias in your shell session as well. It's totally allowed. So now we have a pod running, which is great. I also have a Minikube dashboard up, so we should be able to look at this. There we go. Close all this other stuff, and we should be able to go to pods, and there we are. We'll go to workloads. You can see it right here. Everything looks gravy. So let's say we want to account for users hitting our front end and needing to scale because we just have a lot more web traffic than we thought we were going to have. You could build a second pod, but then if the traffic dies down, it's the middle of the night, it's a weekday or something like that, you would also need to scale back in. So much like an auto scaling group would do with an EC2 instance in AWS, this is how we would do this in Kubernetes. We would do this with something called a replica set. So let's go ahead and get started with the replica sets. So the commands for replica sets are basically the same as pods, and the file structure is actually also the same. The values are slightly different, so we'll go ahead and go over that now. So I'm going to create a replica set definition file, and so we'll just make one called like replica set definition 1.yaml, and we're going to make a second one as well. So for the first one, you have the same root properties. So you're going to have your API version, you're going to have your kind, you're going to have your metadata, and you're going to have your spec. All right, so for API version, the difference is instead of v1, you're going to do apps/v1. Instead of pod for the kind, you're going to do replica set. And for metadata, it's pretty much the same. The name of our replica set for this first one is going to be called front end. And for labels, I'm just going to say app is also called front end. Now spec. For the pod, if you remember, we have our containers, and we just list out our container image and properties. Well, here we actually aren't going to list a container. We're going to match what kind of pods we are going to manage, because remember, this is going to manage multiple pods with multiple containers. So we actually need to use something called a selector, and the selector can match expressions and it can match labels. So we're going to show match labels, and we're basically just going to look for any label that we want to manage. So in this case, you can see the metadata of our pod. The label we have is app, and the value is front end. So we're going to do the same thing. So we're going to match anything with the app front end label is going to be part of this replica set. And that's pretty much it. That's for the selector. The next thing is you need to say, well, how many do you want? So let's start with 3. And then we're going to provide a template. So the template is what defines the actual pod and the image contained inside the pod. So since it's basically the same thing, what we're going to do is we're going to copy this. You do not need to copy the API version and the kind. The template knows that this is a pod, and the kind is actually already defined up here because it's part of a replica set, and the API version is also already described up there. So I'm just going to paste this indented, as you can see, and the indentation is going to not work. So we're just going to use Alt Control arrow down, and I'm going to tab this over twice, and now it's indented correctly. So recap. We have an API version, apps v1, a kind is ReplicaSet, the name of our ReplicaSet is frontend, the label is app frontend, the spec is going to say we're going to use a selector and match any labels, app and frontend, to be part of the replica set, provide 3 replicas, and inside the replica for each pod, we're going to use this template, and we're going to have a container called Nginx, or a pod called Nginx with a label app frontend, and inside of that pod, we're going to have a container that uses an Nginx image called Nginx with these resource limitations. So that is a replica set. So we can go ahead and check to see, do we have any replica sets with the kubectl get replica set, and this is searching the default namespace, and it says we don't have any. So we can do a kubectl apply with a file, replica set definition 1, and we'll go ahead and create it. Now I can check my replica sets and see, here it is. Here's my front end replica set. It's got a desired number of 3 pods. It currently has 3 pods, and 1 of them is ready. So we run it again, and now we have 3 ready, and that looks great. Let's go see what that looks like on the dashboard. This is interesting. Look at the name of my pods. Front end dash bunch of garbage, front end dash bunch of garbage, Nginx. So why is that? Look at the time that these are created. 31 seconds, 6 minutes. If you remember, when I first created this pod, it has the label app frontend. Therefore, the Kubernetes ReplicaSet saw this pod and said, hey, this has the correct label. It can be part of the replica set, so I only need to create 2 more. So the nice thing about replica sets is it will actually adopt existing containers so long as they have the correct selector, which we are not going to go over replication controllers today, but these do not. But yeah, that's pretty cool. So let's say we want them all to match, and plus we want to keep things fresh. So we're just going to delete this pod. So we're going to do a kubectl delete pod Nginx somewhere. There we go. Kubectl delete pod Nginx. Now, what do you think is going to happen? What do you think is going to happen? Kubectl get pods. Well, it went ahead and created another one. You can see this one's 9 seconds old. And if we go look at the workload status on the dashboard, we can see the same thing. So this looks pretty good. I think we did a great job. So let's say we want to now deploy a second replica set. So I'm just going to copy this and paste it into our replica set definition 2 file. And we're going to change this and make a backend. So let's just do a find front end and replace with backend. Boop, done. So our name is backend, label backend, spec selector. It's going to pick everything with the backend label. Let's say we only need 2 replicas for the backend. And the name of this, let's just say it's a Python backend. Let's say it's like an API. And so we're going to use a Python image. We'll name it Python, give it the same specs for resources. And that looks fine. So I could do kubectl apply -f replica set definition 2. and it says it when created it. So if I go kubectl get replica set, I can see I now have 2 replica sets, and I have desired, current, and ready is 0. Ready is still 0. I'll be like, maybe it's just taking a long time, or maybe there's some kind of problem. So how would we find that? So this is where you start zooming in a little bit. So we're looking at the replica set, which right now is the largest thing that we're working with, other than the cluster itself. So let's say we want to describe the replica set, just like we did with the pod. I could do kubectl describe replica set, and then let's pick our backend, so then that's the one that's broken. And I can see here that it successfully created the pods from the replication set controller, and everything looks fine. That's weird. So everything looks fine here, but we can see that there's something wrong with the pod. If I do k get pods, because the pods were created successfully, the front end looks fine. The back end, this one says completed, but it's been restarted twice. This one's in a crash loop back off, and now they're both in a crash loop back off. So how would we go look at what's wrong? Well, you would use kubectl describe pod, and then let's go look at one of these and see what's happening. So it looks like it got started, created the container, pulled the image, started the container, and then failed. I wonder why. So let's go take a look. Now we haven't gotten into the logs in the command line yet, so I'll just show you a neat little trick in the dashboard until I start going over that, because that's a whole nother section I'm going to go to get into down here. But at least for now, if we click on one of these broken ones here, you can see a little bit of information about it. You can look at the events, which we kind of already saw, right? But what if we want to look at logs? So from the either workloads or the pods section, you can actually grab this guy and look at the logs. You can log in and get a shell session. You can edit the pod, and you can delete the pod as well. And you can see these are just continually restarting, and there's something broken in them. So let's find out why. So we go into the logs. The selected container has not logged any messages yet. So there's something inherently wrong with this Python container, because the image has some requirements that it probably needs. So if I just change this to Nginx, just like the other one, for example, and we redeploy it, kfif, what did I call this? Replica set definition 2. Then we can go see, okay, if I change the container image to something that I know works, does that work? Now, what it's going to happen is if you change the file, these containers still meet the requirements of the replica set because of the label. So they're not actually going to get deleted. So if you want to get rid of them and try this new file, you actually need to delete them, which sounds silly, but it's true. So what we need to do is we need to do a kubectl get pods, and then we're just going to do a kubectl delete pod, and just paste that one and paste that one. The replication set will see that these have been deleted and know that it needs to create 2 more and use our new file configuration to do so. And let's see what happens now. Okay, now we see they're running and ready. So the reason for this, if you don't know, if you use a Python image, there's a couple other parameters you need to pass, and we'll get into a more advanced thing, but I just wanted to show you that if you have a broken image, there's ways to look at things, and even if you're using Minikube, there's ways to kind of dig into that inside the dashboard that I think is really useful. Sometimes you don't have the luxury of having a dashboard, so you might need to know how to do this from the command line. I'm not going to go over logs today. We're just looking at replication sets, but I did want to at least show you that if you do have a problem, you have to actually delete these and then let the replication set redeploy with the new configuration, because even if you save it, it's not gonna work. So let's say now I want to scale our front end to 5. So all I need to do is do a kubectl scale replica set, and then let's pick one, front end, and we want to say dash dash replicas equals 5, and do a get pods, kubectl get pods, and now you can see I have 5. The downside to this is that if you scale them, you are now no longer documenting the state of your infrastructure in here. So again, this goes back to what I talked about before, where this is an imperative way to declare your infrastructure, and this is a declarative way. So the more correct version would be to update this file. Let's say we want 3, and we only wanted 5 temporarily. Well, if I do kubectl apply the file for our replica set definition 1 for our front end, it says it's configured kubectl get pods, and you can see it's already terminating those 2 extra front ends. So personal preference, you always want to go declarative. You always want to be declaring what you want in your infrastructure. Imperative is dangerous. I don't even like giving people permission to do imperative commands, because imperative provisioning of resources has no real tracking unless you really dig into the logs and have very specific catches for that in your logs. So anyways, that is it for the file section. If you want to rename these, you can. So if I wanted to rename this like replica set dash front end, because let's say we refactored our code and we redesigned our infrastructure, and this just makes more sense because nobody knows what replica set definition 1 and 2 is. You can do that and do a kubectl apply -f replica set front end, get your pods, and it doesn't change anything. So the content is what matters. So it's okay to rename these files. Unless you have other files that are referencing these files, then that becomes an issue, but just figured I'd show that. And in this case, you actually don't need a pod definition file anymore, although I think it is nice. I really do wish, instead of having this for a template, I could do like path equals like /pod definition.yaml. I would love for this to be a thing, and then I can just manage this, but it's not. So alas, we will do this. I just hate that the metadata spec is repeated. I don't like that at all. Personal thing, you don't need to know that. Okay, so we can see how many pods we've got. We've scaled up, we've scaled down. We know how to look for the replica sets, how to look for how many pods in a replica set. You could look at it like this. That might get kind of confusing. So you can also describe your replica set and do kubectl describe replica set front end. Let me make this bigger. And you can see here I have 3 replicas. I have 3 desired, like the status, I have 3 running. So you can see that a little bit easier. So if you have 100 of them, doing a kubectl get pods is going to be a little daunting. There's no way you're going to know how many there are. So you might need to describe your replica set to get that kind of information, which is nice. And it's easy if somebody's asking you, well, what image is the container using? How many different kind of containers are there? Are there any CPU limits? Like yada, yada, yada. The kubectl describe replica set will give you all of that information right here, as well as some recent events. Again, we'll get into logs later. So as far as how many pods are ready, you can see there's 3 running, which would mean that they're ready. So if you're used to running kubectl get pods to see how many are in the ready state, the describe will also give you that right here. We talked about where to find the image and how to find stuff that's not ready, like with looking into the pod and whatnot. We can delete pods and they just resurface. We know that because the replica set's job is to just make sure that the desired number of pods matches the current state, right? I did this before, but just to reiterate, if I see that I have a backend pod here, I've got two, life is grand, everything's working fine, and I delete this pod, all that's going to happen is it's going to get replaced. So you can delete a pod in a replica set. Just know that it's going to get replaced immediately. If this is annoying and you're like, why I'm deleting this and it just keeps coming back, it's because you have a replica set and you need to either edit your replica set or delete the replica set and redeploy whatever it is that you wanted to deploy. And if I wanted to do that, I could just kubectl delete replica set backend, and now my entire backend has been deleted. And I could do a kubectl get replica set and see that all I have now is a front end. And if I wanted to do some surgery on this or whatever, I could. Now, if you want zero downtime, there's no reason to do that. You can just do an apply. So now I have these replicas, and if I needed to do some kind of major surgery to make sure that this is running, I could edit that. Like, this is no longer a Python. I need to edit this, and maybe I want 6 of these now, and this CPU, I want to change some resource limit or something like that. Like, you could do that and then just apply the backend instead of deleting and recreating. So there's no point. You might as well have zero downtime, right? And you can watch this scale. And it's more fun to watch it in the console, I think, than just hitting over and over and over. And there we go. I've got 9 pods running. Some front end, some back end. Pretty cool. Let's see, is that it? I guess let me pause the video. I'm going to break some files, and then I'm going to see if you can figure out why it's not working. Okay, so we're going to get our replica sets, and you're going to see that the backend is gone. And you have been tasked with getting the backend up. We don't know why it's down. So you get the backend file, and you go look at it, and you say, okay, well, let me just try to apply the last stated file, right? So you do an apply, you replica set for your backend, and you get this error. Resource mapping not found for name backend. Namespace default from replica set backend. No matches for kind replica set in version v1. Ensure CRDs are installed first. Okay, so what is broken? What does that mean? Well, it should be pretty obvious, but in case it's not, it's because the version v1. If you remember, this has to be apps/version v1. And if I were to try to apply this again, you'll see that it's been created. I can get my replica set, and there it is. So that is the first thing you want to look for. Even tiny little stupid things like that, they will make it break. Okay, let me break something else. Okay, I went ahead and deleted the front end. So now your front end is gone, and somebody tasked you with getting the front end back up. But when you try to do a kubectl apply replica set front end with the file, you get this error. What does this mean? Replica set front end is invalid. The spec template metadata labels. So you see this dictionary? This is actually a data structure. It's spec.template.metadata.labels. So if I were to come into the front end file, spec.template, here it is, template, dot metadata, here's metadata, dot labels, It's telling you exactly where the error is. Invalid value, map, string, app, web app, selector does not match labels. Okay, so here's our selector. We're matching the labels app front end. But in our template, it says that the metadata of our Nginx container image has a label of web app. And if you remember, I said that if this doesn't match, then it's not going to work. So we actually just need to change this to front end. And now we're good. Hooray. Peace has been restored to the galaxy. I'll go break one more thing. Okay, last thing, you need to update this, and you're getting the following error. So kubectl apply the file, Hello. Clear. There we go. kubectl apply. We want the file ReplicaSet front end. Okay, it's configured. Everything looks good. Everything's working. Okay, get pods. Everything's running. Everything looks great. All right, and then so these are 72 seconds old. That's really old. So we just want, not really, but we want to delete this one, and we just want to replace it. Have the ReplicaSet replace it. So we just run a kubectl delete pod, and we just delete this one. And then ReplicaSet just recreates it, right? So do kubectl get pods. Uh-oh, something's broken. There's red stuff. The boss is mad. This one is broken. Let's try looking at the dashboard and see if we can figure it out. So we got an event. It did an error, image pull, access denied, repository doesn't exist. Maybe you need to do Docker login. We're not quite sure. So take a look at this error and what do you think the problem is? Well, if you'll notice, I used hacker speak, and Nginx has a 1 in it instead of an I. That must have been a typo. Or maybe Mr. Robot was trying to make a Kubernetes cluster. So we just need to change this. So we do change this to an I. And then what happens? If we do a kubectl apply -f, what's going to happen? It's going to go, oh, I need 3 pods. I already have 3 pods, so life is good. And it's not actually replacing this. Yeah, but we made a file, so what we need to do is we need to delete this one. So I'm just going to copy this, and I'm going to say kubectl delete pod, boom. And it gets deleted. It will get replaced with a new one. The new one will have the correct image name, and all should be right and well with the world. So let's go take a look. Here's our failed one, and now it's running. Perfect. Okay, so that pretty much covers ReplicaSets. So we're going to go ahead and get cleaned up now. So we need to delete all of our pods, right? No, because what happens if we delete the pods? They're just going to get recreated by the ReplicaSet. So we actually need to delete the ReplicaSets. So here's our ReplicaSet names, and I can just do kubectl delete ReplicaSet backend space frontend. They've both been deleted. If I do a kubectl get pods, I can see here they're all terminating. If I do a kubectl get ReplicaSet, there's nothing there. So we just wait for our pods to all go away. And once they're gone, then we've cleaned up our resources. So there's your overview on ReplicaSets. The next thing I'll be going over is deployments after I put some stuff together for you. And if you have any questions, let me know. But if not, yeah, go make some ReplicaSets.